Good afternoon, everyone. We are here from MG Motor India, an automobile-based company based in Halol. We are a family of around 2,000 employees, and I can proudly say that 37% of our employees are all female employees. So, we started our journey in 2018 by introducing our first ever car, Hector, India's first internet SUV, followed by ZS EV, India's first pure electrical car, Gloucester, India's first car with ADAS in its features, and then Esther, India's first car with AI inside. So our goal is to seek continuous improvements using digitization in supply chain. So let me just give you a vivid picture of what our complex line is. We have one single general assembly line consisting of 46 stations, on which we are producing three different car models. Now, these three different car models are having different varied complexities. It could be in terms of seating, transmission, fuel type, and so on. So, if I continue all of that, so when we introduced our first model, we had around 431 different type of variants, and in a single assembly line, we had to accommodate 42 parts per station, which was quite feasible for us. But with introduction of the next two models, the part intensity that we had to keep on the line side came up to 82 parts per station, and anyhow, this 82 parts per station is not feasible to keep all the parts on the line side. So it was a huge challenge for us. So what were the issues that we were actually facing because of that? The first one was delayed feeding of material online. Supply chain, the goal of supply chain is to feed the correct part at correct time on correct location, and that is what we were missing. We are having a so much high complexity that we could not feed the parts correctly. Second, wrong sequencing of parts. Whenever the material is brought from warehouse, it is usually in the wrong sequence as the car. And then we found out why we are facing so much problems. So we came out with a solution that actually we are having a lot of human dependency, and that is why these problems are coming to us. There was no better 5S maintenance on the line sides, and all of our work was done on papers by human people. So that is why this error proofing needs to be done. So I'll just, that's when we started the brainstorming, and we came up with the first solution, but why not have extra manpower? Then again the same problem, extra manpower, more the chances of errors, not a feasible solution. We started to have less of reduction, less of sequence families, and more of keeping the parts on the line side. But again, there was no line side space available for keeping the parts. Then we thought that frequent audits could help us, but proper adherence to that audits was not possible for us, and a complete digitized automated feeding system was completely out of scope to integrate with our current systems. So then we thought that why not have some semi-industrialized or semi-digitized solutions for that, and that's when we started our operations. So for feeding the material to the line side, there are three different line feeding strategies, starting with sequencing. Sequencing is basically the parts will come in a trolley in the same sequence as the cars. For example, if I talk about engine wiring harness, so the first wiring harness will go to the first car, second wiring harness to the second car. Now imagine we have 50 such part families, and especially in engine wiring harness and parts like that, even a small connector could make that part different. So how can a person with naked eyes can visualize all of that? So we came up with sequence feeding enhancement project. So I'll just show you the project, how it works. So earlier we were having a run sheet or a paper-based run sheet wherein the part number will come and the operator will pick up the part accordingly. But then we digitized it. We got to know that on most of our parts we have some QR codes or barcodes or some type of identification factors which we could use for error proofing. So we used one HHT in which, as you can see, the part numbers are already coming, and the operator will sequence the part as per the part numbers which are coming, and then after the sequencing he will scan the parts in the same sequence. If he is sequencing the wrong part, the red light and a beep alert will come. So this helped us in improving our downtime and sequencing activities, and we significantly reduced the paper and made this a more sustainable solution. Next is kitting operations or kitting parts. We are having around 490 parts which are to be kept on the single trim line. which is the first line, having 15 stations. Now 490 parts, 15 stations was not possible. So what we did was, we made a special area wherein we will make a kit out of that, which all parts are going into that car, and accordingly that kit will move along with the car. That is basic kitting operations. So it was again leading to, it was since human intervened, so it was again leading to a lot of errors, and again the paper-based kitting was happening. So we introduced one smart kitting system. So whenever the trolley comes into the kitting area, the operator scans the trolley. The trolley will be having the car details for which it is being made. Now the lights will glow. Only the lights which are for the parts which are to be fed in the kit, only those glow. And the operator will simply pick up those parts and then acknowledge that, okay, I have picked that parts, and that's how the car, and then the next zone of lights glow. So that's how the complete sequencing happens. And whenever the car comes on line, the kit is already ready to go with the line. So that was in the enhancement in kitting operations. Now we are okay with kitting operations, we are okay with sequencing operations, but what about the parts which are kept directly online? Any operator can pick up the wrong parts. So for having that problem solved, we had an e-Kanban system. E-Kanban system basically means that initially when you have to pick up the material from the warehouse, you had to have one Kanban card, which you had to fill up that I want this much quantity, that you have to give to warehouse people, and warehouse people will return back the material as per the Kanban card. But in that, the problem was there that Kanban cards used to get lost, or they could get teared off, and then the material could not be fed on the line side. So we came up with the e-Kanban system. E-Kanban system basically is the QR code based system, wherein on the line side we have kept all the materials that we have along with a QR code. So whenever any operator, we'll start with the e-Kanban system again. So traditionally what Kanban system used to have was, we were having Kanban cards. We used to give it to the warehouse person. He will bring the material as per the Kanban card and bring it back. But the issue was that Kanban cards were getting lost, or they were getting teared off. So we came up with the e-Kanban system. As you can see, there is this QR code against each and every part. So the scanner, person's line side operator simply has to scan the QR code and give the requirement that I want 2 boxes. Immediately the trigger goes to warehouse, and then warehouse can replenish the material. Now, what was the benefit for that is because of this technical system or technology, the complete communication between warehouse and line side, which was earlier being done on walkie-talkies or mails or something, it got completely automized, and we got the correct status of when the material is coming and when the material is when the requirement was generated and so on. Now that we have digitized all our line feeding operations, our next problem was how to call undivided attention whenever we required for any maintenance or supply chain activities or anything. So earlier the system which was used was pull cord system, wherein we had to pull the cord, and the person and all the departments, they will come to the line and they will attend the situation. But the problem was which department has to come and what was the exact station wherein this cord was pulled on. And third was how to monitor how much was the downtime and how much time was taken to solve this issue. So we came up with the digital hand-in system. So as you can see, we are having touch screens over there with 3 different options of manufacturing, supply chain and maintenance. So the operator will call the correct department, and on the hand-in screen, which is shown in the big picture, so there you can see that what exact station the hand-in call was done and what was the impact of that. Moving on, our last one was dock management system. Since it's a huge plant, we have around 16 docks to unload 130 trucks every day. So which truck, when it has to go where, it was a huge problem for us. So we came up with the dock management system. So with all these digitizations, we had really great benefits. We reduced the wrong part supply by 12 parts per day. We reduced our downtime of around 125 minutes per month. Paper usage of 1300 numbers per day. Line side space 450 square meter. And TAT, which is truck turnaround time from gate in to gate out of MGI, we reduced it by 40 minutes per truck. having this standardization along across all the different lines of our plant, we actually developed all these systems in our own in-house logistics execution system, so we can easily deploy it anywhere all across our plant. And all the SOPs have been displayed on the line side, and we also introduced a digital layered audit system to escalate the issues to the management if required. And in future, we planned, since I already told you that this kitting was done only one trim line, we plan to extend it to all the other lines of our assembly shop. And further from this truck management system could only track the trucks from gate in to gate out. So we plan it to track it from the supplier end, and so on. So this was our journey from a completely manual based system to a semi-digitized system. So thank you all for being a part of our journey. Thank you.
Great. Just it's not related to the initiatives what you have shown over here, but my simple question, because you told that initially it was a manual process and you have make it a semi-digitized form. So how this journey, how you educate your people? Because now what I feel, whenever we need to work on any kind of digital initiatives, it's very difficult to change the mindset of the people, and to implement those digital initiatives, it's a bit difficult because of all people who are working since long. So because as I know, this MG plant is old GM Motors plant, the same manufacturing facilities is being used, right? So how do you change the mindset of the people?
So I work on the shop floor. I take care of the shop floor activities. So this is what I do, that mentoring the people who use these systems. So initially what we face the issue is that they don't adhere to the system. They keep thinking, they keep doing. So what we do is we provide regular trainings. If that does not help, what I personally try to do is because of these systems we are able to reduce the manpower, we increase the quality of manpower. The better quality manpower is hired, so we can actually work. If say 10 people were working manually, so now 4 people who are better than those 10 people can work efficiently with this. So what we try to do is hire better people, hire better quality of manpower. Second is regular trainings, regular adherence, regular trainings of that. If I give an example of smart kitting system, what we do is monitor daily how much efficiently the system is used. See, so if say 200 cars are made a day, for how many cars have they actually used the system, that tracker is there in the system. So we do that, we display to them that you did not use for this day, you use for this day. So accordingly we do for various systems. Yeah. Major thing will always be that adherence is the issue, and so that we hire a better quality of manpower by reducing the number. So the cost does not affect.
Is it the right choice to change the people?
It is the right choice to change. We anyhow, if the person, if manually, if they were doing, if they are not working efficiently, we had to change them. We had to. It is not a permanent manpower that I'm talking about. I'm talking about the 3PL.
Okay, thank you.
I have one small question. What is Kanban?
Yes.
Yeah. Initially, what used to happen is you have a pull call at each and every station, and whenever the operator needs to call someone or needs to call some department, he used to pull that
e-Kanban.
So e-Kanban, earlier we used to have that Kanban cards on which part number and all is written. You just have to write the quantity and then you put it in some card slot. And then the warehouse operator will come, he will pull up that card slot, he'll see and he will replenish the material. With e-Kanban system, what we bought is at each and every live location, we are having this white colored QR code with part details and where the material has to pull from. All the details are available all over there. So what the operator does is he simply scans the QR code. After scanning the QR code, he will write his requirement pieces that I require 4 number of pieces. And this trigger directly goes to the warehouse team through digitized systems only. We are having that trigger system. So that the warehouse will know that, okay, I have to replenish this many number of parts on this particular line side location, and he will bring that material. And after bringing that material, he will acknowledge that this is how my material has been replenished.